Morning, everybody. I am Marco Cavallini of Coan Software Italy. Today I'm introducing you this topic about how to develop Linux kernel module outside of the kernel tree using the tools provided by Yocto project. In particular, we are using DevTool. DevTool is a collection of commands or options and tools provided by this command included into Yocto project and also into the eSDK component. So basically this means that you can develop everything inside the Yocto project when you have set up the environment properly, or you can build the system with the eSDK and redistribute it to other colleagues into your company, and those wouldn't need to use the full Yocto project environment, but basically is a copy of it where they can do basically the same things without using it directly. Okay, so we can, in this case, we are going to create a new recipe using this dev tool, and we are trying to include it into a final image. So we are going to, I'm going to explain to you. And this set of slides, I want to show you every step which is needed to be accomplished, and afterwards we can start together practicing everything directly in the virtual machine. So it's not necessary to start now working directly, entering the commands you see here. When we are working with kernel modules, we have basically two choices. The first is to use to develop the kernel module outside of the kernel tree. That means that the code is in a different directory, and the only thing you need is to have the sources or the include files of the kernel. And the other option is to have it into the kernel source tree. And in this case, it's perfectly integrated into the build system and the configuration system provided by the kernel. So using the kconfig system and integrated with a proper makefile into the kernel directory. Page down. Okay. Okay. And now let's analyze the differences, pro and cons about the two choices. This is a kernel module outside of the kernel tree. We have the advantage of have a lighter system and an easier way to develop the module, because we don't need to integrate it perfectly into the kernel tree. The drawbacks, of course, is that it is not integrated. When you do make menu config, you won't have it into the menu list, menu options. It needs to be built separately from the kernel itself, and the driver can be loaded statically into your monolithic image. Okay, there is something weird happening. Okay. If you are working into the outside of the kernel tree, inside the kernel tree, we have the advantage of having everything into the kernel, so we can see our new kernel module into the options provided by the menu config. The drawbacks is that the kernel size may be larger in case you, kernel size from the sources point of view, of course, because you have the sources of your component, and the final image if in case you put it into in a static mode into the kernel. And this may may result into a slower boot time. This depends on the amount of tasks your kernel needs to execute, of course. Here we have here we have the simplest kernel module we can develop, and we are going to use it for our exercise. And it is presenting a message when it is inserted and connected into the kernel with the modprobe or insmod command, and exiting another string when it is discharged from the kernel. What we need to build this kernel module is to have a proper makefile, and in this case, the makefile need to specify the location of the kernel sources provided by the kernel src variable, and this allows the system to build it directly using the Yocto build system or the DevTool build system. The sources of this exercise of this driver are provided into the GitHub link below at the bottom of the page here. And what do you need to do to set up the system? First of all, you need to enter these commands to prepare the environment, and particularly you can notice that we have the populate SDK option. The third line, the bake for image, the -c populate SDK text is the one that is able to create the eSDK, including the DevTool package. This is already done from us, so we can speed up the setup of the whole course. And after that, we have into this directory scratch SDK QEMU everything set up for you. And we are going to start from here. And we need to simulate that we have a target board, and in this case we are using a QEMU ARM system. So you will need to open two different terminals, entering the connecting with the credential you have here, and you need to set up the environment in both the windows. So on the host side and on the target side, you need to call this command source environment setup that is preparing everything for you. In this case, afterwards you can use the command, you can call the DevTool command. If you want to be sure that everything is okay, after that you can run DevTool -help or DevTool without any option, and you see that it is working and asking you for more details, of course. After that, you need to build an image. Okay, the image should be already prepared for you, but if you want, you can run it again, and it takes a few minutes to build. And this will create for you a new image into the directory below. So here you have the system prepared for you, and on the target window, you can run QEMU no graphic. This means that you have the system, the target system started with the QEMU, and you don't have the graphic interface that can be not convenient during this test we are doing. The login is into the target system, require only the user, which is root, and there is no password. On the other window, we are now starting working on the target system, on the host system. We launch a DevTool add specifying the name of the recipe we want to create. So the DevTool add is the option that creates for us a new recipe called simplest module, and we're setting it with the last parameter where the sources are located. In this case, the sources are already into our machine, and that they were downloaded using git clone from the GitHub I showed you earlier. And okay. After that command, you we'll have into the express SDK QNOR space directory this source, this tree of file and directories. And the workspace directory is where DevTool is placing its artifacts during the creation or modification of existing or new recipes. So you can find everything you are doing inside here. The resulting components built from the build process are listed into another directory I'm going to show you. So in this case, we have the new recipe for simplest module underscore git, and here we have the appends. In case you have, for example, you need to customize an existing recipe. Now that the recipe is set up, the sources are already present into the system, you need to call that tool build name of the recipe you want to build. And this will create the simplest module KO, which is the kernel module we need to load into the target system. This command usually downloads the kernel sources at the first time. So this is an activity already prepared for you, just not to spend too much time downloading something from the internet. And okay, but I listed it for your convenience at the bottom of the page. After the compilation, you need to run devtool deploy target. And how can we know where is the IP address of the target system? On the target window, we run ifconfig to see that our IP address is 7.2, and with deploy target -s name of the recipe, we can log in and do an SCP connection, transferring the artifact of our compilation. You will get on the host side these messages showing you what is executed into the target system, and the directory where all the artifacts are deployed into the target listed here at the bottom. And when you want to start and load your kernel module into the target system, you need to prepare the dependencies of kernel modules using depmod-a, and with modprobe name of the module, you can now load it and connect to the kernel. In fact, when you will run lsmod, you will see it listed into the list of the kernel of the modules loaded into the memory. If you want to remove it, you can try also this command. And an additional option is, for example, to automatically load this module when the system starts, and is done editing creating a new file into the target system, etc modules load hello.conf, for example, and simply inserting the name of the module without extension, like shown here. And you can try to remove the target system just to see that everything is working. So starting from now, your system is will load your module automatically every time. Okay, after I introduced you all the path, all the steps you need to do, we can try to execute the lab. Maybe many of you have already finished because this is an advanced class, but anyway, I can try to show you everything on my side. So let me try to disconnect this one. And okay, how can I do that? Okay, larger set of character and monitor. Okay. No, it's too small, even. Okay, first window and second window. Okay. Okay, this is the target. Now, the slides are here. Slides are here, and okay, we can see that the sources are already set up the machine, which using this bash and source environment set. Scratch. Source environment setup on this side and Scratch SDK QMR source environment setup on this side as well. And now, okay, I can build the image on the host. If you have any question, please ask me. While I'm building on the host side, I can start the run QMR graphic on the target window.
No graphic, OS.
Yeah, thank you. Okay, yes. I'm building the kernel here. So, or if you skip the kernel build, so I mean you skip DevTool build image, you are already able to launch the target system in case you need to wait 1 minute.
So I'm at the QMU login.
Okay, the image is almost finished. And now we can start it. Okay.
Yeah, I got it. Yeah.
That's on the host side.
Simplest.
Ah, yeah. Okay. Simple. Thank you. Crazy. Ah, yes. Simplest. Simplest. Okay, on the target I have login. If config is showing me that this is my IP address and the current modules are loaded are these. On the host, now we need to yes, in fact, here was correct. And okay, now the sources are already present, so we need to run devtool add name of the module. And we have everything created into this directory. Okay, there is also the kernel sources inside it. So we can do 3 L1, for example, and or enter into workspace. Yes, workspace. Okay, and 2 levels, for example. Okay, you can see we have the appends for the kernel, and because when I built the pre-built kernel, built the other day for you, created this one, but in this moment we are using the simplest module give append, and the recipes, the actual recipe is into this recipes directory, and now we can build the module. So DevTool is calling bitbake to build it. And into the sources directory, because we are into the recipe we are using is specified to keep it to keep the original sources. We can see what we have inside this directory, for example. Okay, we have everything into this directory. We have also the key.o file, which is our kernel module. Now we need to transfer it to the target system. And the command to be used is devtool deploy target. Okay, everything is transferred to the target, and here I decided to say okay on the target, and we need to do dep mod -a and after that mod probe simplest module. Hello kernel, sorry, because the simplest module is the recipe. Hello kernel is the module itself. Hello kernel, and now the print K has shown the 2 lines, and ls mod is saying that the module is loaded into the memory.
Is there a typo? Is that supposed to be simplest model?
Yes, in fact, sorry, there is a typo. Yes, here is correct, but into your slides is simple module and instead of simplest.
Typo on page 1.
Which slide is that?
Slide 10.
Slide 10.
Yeah, just a typo. It's correct. Second half of the slide, on the first half.
I have problems using PowerPoint into a Linux machine.
It's not 10.
It is exactly.
It's actually slide 22.
24. Yes, 24.
24, it's the type is wrong.
Simplest. Okay, I can save it. Simplest.
There you go.
Okay, I think so. I'll post it later. Thanks.
Okay, and continue with my PDF here. And okay, the module is loaded, and starting from now we can load and download the module every time we want until it's completely developed without errors. And at the end probably you need to load it automatically. So on the target we are editing this file and entering the hello kernel. Hello kernel.
It's modules load.d. Yeah, typo again.
What page?
29.
Where, sorry? 29. Ah, okay. Hello conf, hello kernel. Yeah. Hello kernel.
It's etc modules load.d. The file doesn't exist.
The file have to be created. Hello.conf. Yes, thank you. Load.d. Hello kernel. Okay. And now we can reboot the QEMUR machine. Okay. Hello kernel is presenting his strings here. So loaded, the message loaded, and the message sent out by the init. and still waiting a complete boot.
Here, it's not
Of course, I need to kill it on my site.
no trying to get walking against what you did. And I'm going to see
Were you able to run it? Were you able to load it, load the kernel, load the module, everything? Do you need something, any question? Okay, the module is loaded. As we have seen, it is hello. And of course, we can't unload it because it's no, we cannot unload it because it's mod. Yes, we can unload it if we want and repeat it. Mod probe. Okay. So, if you have any question about how to integrate modules into the step 2 mechanism, please ask, or if you are were able to load it and the exercise is completed, thank you for everything.
Thank you.